Let's go and let's review first the define log normal, beta, and normal inputs. When you select that particular input, there are 4 worksheets that are associated with that. As I showed you last week, there is this new notes worksheet, which allows you to go in and put down some commentary with regards to the analyses that you're doing. So this notes worksheet is always available, just as the start is. For those of you who have used Toolbox in the past, you will remember that there is a log normal parameters worksheet, which allows you to go in and build a log normal distribution based upon any 2 percentile value inputs, so that the way that you modify this, for instance, is to put in a value for a P99 in the light yellow cell and another value in the P1, and it calculates the full percentiles associated with that. So there's a variety of different 2-cell inputs that can be used to build this log normal distribution, potentially for you to take those P90 and P10 values and use them to build a distribution over an MMRA or ROSE-RA. What's new is this log normal beta normal worksheet, which actually compares in a side-by-side manner log normal distribution, beta distribution, and normal distributions. Again, the input values that you can use are in the yellow cells. What's new about this particular worksheet is that it allows you to go in and capture the data in different manners in any percentile values. So you, for instance, you could select to input on row 6 either the percentile or the mean, and you can put in any value that you wanted in here. So just type in an 85, for example, and that allows you to put in the P85 value associated with that. And of course, you can go in and modify the inputs as appropriate. And you can see that the probability density function chart down at the base updates based upon that. So I'm going to go back to the original values that were in here. And what you can see is that I've got similar values across the board for the log normal, beta, and normal distribution. One of the things that is readily apparent from the inputs in here, and the calculated percentiles are shown to you in the green cells below the yellow cell inputs. But what you can remember is that in a log normal distribution based upon the input percentile values, that the mean is always going to be greater than the median, is always going to be greater than the mode. And it's easy if you take a look at the normal distribution at the far right. You can see that as would be expected in the normal distribution, those 3 parameters of central tendency are exactly equal with all the values of 30. And you can see that the beta distribution with similar inputs has a different shape as well. So you have free flexibility to go in and modify, for instance, percentile versus mean, or a P10 P90 ratio, and that same functionality is available for the normal distribution. The beta distribution gives you a little bit more flexibility about how to input those particular values with means and percentiles and standard deviations, successes and failures, and alpha betas. So I think one of the ways that you can use this particular worksheet is if you don't have a sense as to what is the appropriate distribution shape, but you have an idea as to what are the percentile values that you're taking a look at, then you can quickly go in and see how what would be the change in the shape associated with the inputs as you modify based upon the distribution shape. The beta distribution, remember, right now its mode is toward the low end, just as is the log normal distribution, with the mode on the normal being symmetric. But based upon the input values that you put in, you of course will change the shape of the distribution. So remember that the beta distribution can be asymmetric, either with the mode either to the left or the right, or in the center associated with it. So nice visual effect in here that provides you insights as to, based upon different percentile values that could be taken over and model a particular parameter either in ROSE-RA or in MMRA. The next new worksheet is this P90, 50, P10 inputs to test as to whether the inputs are log normal or normal. And what this allows you to do is for different cases in here, in this particular worksheet, there are 5 different cases. And once again, in the yellow cells, you can capture numeric inputs so that you can test if I had a distribution of 10, 20, 30, is that more of a normal distribution, or is it a log normal distribution? And when you input 3 numeric values, you can take a look at the log normal test, which is shown in these cells, versus the normal distribution test. And what this is doing is, for the log normal, is taking ratios of the P10 to the P50 and the P50 to the P90. If you divide those 2 ratios, then a log normal distribution would be equal to 1. So in this particular example, it's 10, 20, 30. It's not, the ratio is not exactly equal to 1, so it's suggesting it isn't quite a log normal distribution. When you look at ratios of the differences between P10 and P50 and the P50 and P90, the ratio of those should equal to 1. So these inputs of 10, 20, 30, with the ratio here of 1, it's indicating that that is a log normal distribution. Differentiate that from case 2 in here with a high side P10 input of 40. Here you can see that the ratio is 1, unlike the normal distribution ratio of 2. It's indicating that those inputs have more of a log normal shape. You also have the ability on this sheet to only put in any 2 inputs, the P90, 50, or P10, and it will calculate and display down below what would be the 3rd input based upon those values. Finally, the last item is for those of you who have attended the Rosen Associates 5-day prospect course. You'll remember that Ed Capon had gone in and several decades ago had shown that when you multiply log normal distributions together, that he provided a mathematical treatment that if you wanted to determine, for example, in the upper box, if you wanted to multiply some number of distributions, and for example, 3 distributions, and you wanted to know what would be the p-value from the 3 input distributions that when they multiplied together would equate to that percentile, then the brown cell is indicating that if you multiply the 3 P77s together from the 3 inputs, that would equate to the P90. These are free forms so that you can change this if you wanted to look at the P85 for 2 distributions. It says go and retrieve the values from the P77. The lower table is providing similar inputs for 3 distributions here. If you multiply the 3 P90s together, then that equates approximately to the P99. But you could go in and modify this for for whatever inputs values you're contemplating and the number of parameters that are being multiplied together. Now remember that this mathematical treatment is only valid for distribution shapes of log normal where each of those log normal distributions have similar P10, P90 ratios. That may not be a very realistic assumption in a lot of exploration plays, but where that does correlate, you could use this tool to understand what values to multiply together.